Hello everyone, welcome to my YouTube channel Know About Embedded Systems. In today's video, we will understand what are the important features of FlexRay and what are the applications of FlexRay protocol. So before starting the video, if you are a new viewer to my channel, kindly subscribe my YouTube channel, click on bell icon, like this video and share with your friends and colleagues. Let us start the video. FlexRay protocol in automotive. So guys, what is this FlexRay? So FlexRay is basically communication protocol. Widely it is used in automobiles, nothing but your cars or in your heavy vehicles like trucks and so on. Right, so if you see this example here, this is one car, and in this car we will have different ECUs. You might be knowing already. We will have engine control system, we have transmission control system, ABS system, a steering control system, and it goes on like that. So all these ECUs are connected through a one common communication channel, that is going to be a one communication interface. That communication interface nothing but FlexRay. So it can be FlexRay, CAN FD, or even Ethernet as well. But most widely used communication protocol is CAN FD, and FlexRay. FlexRay is having its own advantages, and why the FlexRay is used in automotive, that we will see. The first and foremost important thing why the FlexRay is used, because of high speed. You can see here the first point, whatever we are mentioning here, the high speed communication up to 10 Mbps speed, your FlexRay communication protocol is able to transmit, and it's very highly reliable. So why it is highly reliable, that I'll tell you later. And also it provides a deterministic communication and a time trigger communication as well. So both it is possible. Whereas in case of CAN, it's a kind of event driven communication, but here we have time driven and event driven both. Okay, all these things we will discuss in this video. Okay, now let us start the first point. What do you mean by this FlexRay, and why it is used in automotive? The first and foremost thing about the FlexRay, basically the FlexRay is a communication protocol which is used in automobile or in automotive to have a fault-tolerant communication. Okay, so if you see the definition of your FlexRay, the FlexRay is basically high-speed and deterministic fault-tolerant automotive communication protocol. Right, so what are the important features? If you observe here, the important features of your FlexRay is speed. 10 Mbps speed. The FlexRay is able to transmit and receive the data 10 Mbps speed per second, 10 megabits per second. Dual channel, we have single channel FlexRay, we have dual channel FlexRay as well. But in case of CAN, we have only one common channel. Within that channel only we have to transmit. But for one single application, we will have two channels in case of FlexRay. I'll tell you in detail later. And FlexRay uses time division multiple access, or you can say it will actually support both time division as well as event driven. Both it will support. And the FlexRay will also support for different configurations like a star, bus, and hybrid topologies. Whereas CAN will support only bus topology. So if you observe here, let us see here. This is my complete car network or ECU network. We have ECU 1, 2, 3 and so on like that, and these ECUs are connected with a common channel. And observe here, very important thing here is, you see here, in case of FlexRay we will have two set of channels. Each channel will have two wires, and each communication interface will have two channels. So why it is required? In order to have a redundancy. If any one channel fails, the other will be in operating. Other channel is going to recover. Okay, so it will not affect if there is any channel fails. That is a very big advantage with the FlexRay. The second big advantage is the speed. So 10 Mbps speed, whereas in case of CAN, it will support only 1 Mbps, and CAN FD will support up to 8 Mbps. Okay. So next point, if you see here, the FlexRay will support two different channels. As I told you already, FlexRay will support single channel and dual channel as well. If you observe here, you can use, if you want to have more reliable communication, then you should have two channels. Even it is possible with one channel, but it is not much reliable compared to two channels. So like that. So this is the definition of your FlexRay. FlexRay is a high-speed communication protocol, automotive protocol, which will support 10 Mbps speed, dual channel, TDMA concept, and also it uses a different bus topologies. Okay, now we will see the important characteristics of your FlexRay. What are the important characteristics? The first important thing is high-speed communication protocol. The FlexRay communication protocol will support up to 10 Mbps speed. Right, this is a very big advantage of FlexRay, whereas I already explained CAN will support 1 Mbps, CAN FD will support up to 8 Mbps. Characteristic of FlexRay is payload. Payload is nothing but data transmission. If you observe here, so payload up to 254 bytes. Up to 254 bytes in a one single transmission, the FlexRay is able to transmit. Whereas in case of CAN 8, CAN FD, it is 64 bytes. Whereas here FlexRay will support up to 254 bytes. This is a second very big advantage with the FlexRay. Third important, as I already told, your FlexRay will use TDMA concept in order to transmit a data timely. It uses a time division concept, nothing but every message will have predefined time, and based on the predefined time you're able to transmit, or your ECU is going to transmit cyclically. Okay, that's called as a time driven concept. The next one, dual channel architecture. This already I have told you. FlexRay uses a dual channel, independent dual channel. So what do you mean by independent dual channel? That means each channel will be operating independently. You can see here I have a channel A and channel B. Each channel is going to be operating in independent way. There will be no physical connectivity, or there will be no logical connectivity between two different channels. If any one channel fails, communication will continue with uninterrupted, because the communication will happen in another channel as well. If you observe here, if any channel fails, obviously the communication will continue even the channel A fails or channel B fails. This is a very big advantage of your FlexRay communication protocol. The next point, FlexRay will support both time triggered and event triggered, as I already explained. So FlexRay is a combination of both event triggered and the time triggered. Some frames will be transmitted on periodically, some messages will be transmitted based on the event. That's why compared to CAN, the FlexRay will use two different concepts, time driven and event driven as well. As I already told you, so FlexRay will support both time driven and event driven. So in case of time driven, nothing but static, this is called as a static segment we will call. In our in our FlexRay frame, we will have two parts. One will be a static segment and dynamic segment. So if you can see here, the blue color, whatever you're seeing, this is called as static segment. This is called static segment, and yellow color, whatever you're seeing, this is called dynamic segment. In case of static segment, the ECU is going to transmit data or transmit the messages periodically with a predefined time. This is called as a static segment. ECU will transmit data periodically. The ECU will transmit different messages periodically. Those messages are going to be safety critical information or safety critical messages. So in most of the applications, safety critical messages or safety critical informations need to be transmitted timely. Maybe every 10 millisecond, every 20 millisecond, or every 50 millisecond you need to transmit. That is called as static segment. And a dynamic segment means based on the event. If there is any event, if for example, if you take an accelerator, if your wheel speed is going more than 100 kph, we will transmit one warning message. Like that, these are all called dynamic messages. So dynamic message based on the event, we will transmit different messages. So this is a one more big advantage with the FlexRay. We will have both static and dynamic message transmission as well. So in our FlexRay, we use global time synchronization. You can see here, each ECU should follow the global time. That's called as a global synchronization we'll call. So with the help of this global synchronization, every ECU will be in a properly synchronized manner, and you can transmit without any errors. High reliable and safety critical automotive applications. That means, as I already told, since we're using two different channels, and also we're using event driven, and also we're using static time driven and event driven, your FlexRay will behave like a high reliable communication protocol, and it is used for almost all safety critical applications. And FlexRay will support all type of topologies, like bus topology. It will support star topology, also hybrid topology. So all possible topologies your FlexRay will support. This is also one of the reasons why the FlexRay is more popular. And coming to the errors detection mechanism, FlexRay is having its own data integrity mechanism or a validation mechanism. If you observe the diagram here, so I have split it into two parts. The total data validation is divided into two parts. One will be header part and one will be payload part. We will have two types of data integrity mechanism. One is called header CRC, you can see here, and one more is called as frame CRC. So we have two types of CRC calculations will happen when you transmit the data. One is your header transmission and one is your frame. One is a header CRC and one is your frame CRC. So header CRC will be having a 11-bit CRC check. You can see here this point. The header CRC will have 11-bit CRC code or 11-bit CRC checksum. With the help of this, we can verify whether the header is correct or not. If the header is failed or if the header CRC is getting failed, entire frame will be discarded. That means this is, so there are two types of two checks we will do, header CRC and the frame CRC. So if header CRC is failed, then complete frame will be rejected. Okay, so this is a one thing. And second thing is frame CRC. So frame CRC, you can see 24-bit CRC we are using, or 24-bit checksum we are using. It's also called as trailers CRC. With the help of this, we are going to verify your frame data frame and the data integrity, whether data is corrupted or not. That part we will check in the frame CRC part. Okay, so this is the data integrity and error detection mechanism in case of FlexRay. This is also one of the important thing why the FlexRay is more popular. And also FlexRay will support both sleep mode and deep sleep mode, and wake up mode as well. So with the help of the sleep mode and wake up mode, you can power consumption you can reduce. Okay, this is also one of the important reason. The FlexRay, as I told you already, FlexRay uses two different channels. You can use single channel and you can use dual channel as well. So when you use a dual channel, so we are going to call it as a channel A and channel B, and each channel will have two lines or two wires. They're called as FlexRay bus plus and bus minus. You can see here, this is a blue color is called as a bus plus, and the red color, whatever you're seeing, this is called bus minus. Each channel will have two wires, and these wires are called as bus plus, FlexRay bus plus and bus minus. Okay, so what are the applications of your FlexRay, where we will use this FlexRay? The first and foremost important applications where we will see is suspension, active suspension, powertrain management, braking system, steer-by-wire. So apart from active suspension, the powertrain is also safety critical application. Braking system is also safety critical application. Steer-by-wire, nothing but steering control unit we will call. That steer-by-wire is also safety critical. So active suspension is not much security or safety critical application, but powertrain, nothing but your engine powertrain. When we say it comes with a powertrain transmission, our engine, gearbox, and so on, right? And a steer-by-wire, nothing but steering by wire. So steering is also one of the critical. Braking unit is also one of the critical application. And ADAS feature. The FlexRay is widely used in ADAS applications, like you can see here, the front camera, side cameras, right, blind spot detection, and then we have ACC, advanced cruise control, AEB, advanced emergency braking system, and then rear cross traffic alert, RCTA, and parking assistance. In these applications, we will use your FlexRay as a ADAS part. Then we have engine control system. In the engine control system, we will use your FlexRay such as crankshaft, camshaft, throttle position, and so on. The fuel injection, ignition coils, so on like that. So FlexRay is a very popular communication protocol and one of the high-end communication protocol widely used in automotive applications, especially like engine control system, ADAS features, ABS, and so on. Okay, so I hope this video is an informative video. So if you feel this video is an informative video, please click on like button, share these videos, and subscribe to my YouTube channel. Click on bell icon.